There is now a open spaces at 145 in room 9 to restart the Triangle DevOps meetups and other meetups. So if you're interested in helping with restarting those meetups, check out that open space at 145 in room 9. I just want to call out thank you for all the folks that wrote that on there and willing to kind of have that conversation. Please give a big round of applause to Shabbat.
Thanks so much. I hope everyone is able to hear me properly, right? Perfect. I hope everyone is having a wonderful day. It's day 2 and day 1 of class, and thanks so much for the inviting to organize this conference. The topic that I'm going to be covering is the importance of CI/CD in the world of DevOps. And I always like to start my talks with Slido. I hope like everyone has probably heard of Slido. If not, I'll just walk you through. But a quick introduction, I'm Shivai. I flew in all the way from India. And I'm probably the one from India actually. So that's really great. And I currently work as a DevOps engineer at Research. It's an open source Rust-based search engine. And I'm also being a Git release team member. Now, what I wanted to start off with is getting thoughts about this particular session because it has been a bit controversial in the past. And what I would recommend to all of you is to scan this code. This will redirect you to slider.com and you can put in that pin code. And the question that I've kind of put up is, what are your thoughts about DevOps and machine learning? Can they coexist with each other? And I just wanted to do this before starting my session to just kind of get to know what the audience thinks about this particular topic. And of course, as we uncover about the concept of CI/CD and how it can be used in the field of machine learning and MLOps, then we will kind of see what are your thoughts. So feel free to add your thoughts and you can see that this is kind of a word cloud. So as you add, the responses will be shown up on the screen. So if someone says yes, they do exist, and someone says I'm learning, I don't know. There's one really interesting answer on hope. So before bots take over, and you never know bots might take over. So we'll probably just take another like few seconds and see what kind of response do we get. So a few people are unsure, some people are saying we need to learn more, but a lot of people also do agree that they do coexist. And of course, the outcome that we try to see is that yes, they can coexist, and they are not actually future, they are being used currently, like both DevOps and machine learning can exist currently, and that's what we're going to be covering. So I hope that this kind of gives me a good idea of like the audience. It's kind of a mixed response. So probably let's get started. So one of the misconceptions that people usually have, and this kind of stems from the previous slide that I also shared. Right? So the talk that I'm giving over here, I also submitted the same abstract to 3 other DevOps days, and I got a rejection with a similar feedback from the review committee that ML is a very touchy subject in the DevOps world, and a lot of it feels very artificial and not practical for the normal DevOps engineer. And if we kind of look at 2 sides of the same coin, whether it's data scientists or it is DevOps. So first, let's talk about data scientists. Data scientists typically write the Python notebooks, they run experiments, they write machine learning models, they evaluate the models, they conduct some tests, they might use libraries like Cbon or Matplotlib in Python in order to generate metrics out of it. But the moment you ask them that, hey, can you help to productionize this model? Because of course, after you have created a machine learning model, the next step is to productionize it, right? So that you can actually use it inside of an ML application instead of a web application or any other software application. But the data scientists tend to stay away from it, right? They get scared and they always say that I just want to focus on my Python notebook and that's it. And whereas with DevOps engineers, they don't really like to get into machine learning. They say that they just want to work on their Terraform scripts, or if they want to work in CI/CD, and they don't want to learn the nuances of machine learning or the mathematics behind machine learning. And of course, given the fact that both DevOps and machine learning appear to be very vastly different fields, it does raise that question that, hey, I mean, are they interrelated or can we really combine both of them together, right? So, of course, I mean, I'll just share some memes to make this more interactive. But the idea is that what I'll try to uncover today is that yes, you can very easily integrate CI/CD or GitOps or DevOps very easily with your machine learning pipeline. But of course, for those folks who might be new, because of course this is a DevOps conference, so if you do not come from machine learning background, I'll very quickly just run down the entire machine learning lifecycle and how that kind of looks like. So usually you start by defining a problem and you collect your data related to that particular problem. For example, let's say a problem statement could be what's the effect of COVID over the past like 2 years in city of Raleigh. So you'll have data points such as like what has been the number of cases that have been there over the past like each every day for the past 720 days. And then once you collect your data, you clean your data because of course you never have data in a very direct to use format, right? So you clean your data, you define your model parameters on the basis of which you will do your feature engineering, basically picking up most important parameters inside of your data set that will be used for doing the model training. Then you train your model, and finally you get your predictions and your results, right? So that's the typical machine learning life cycle. And if, of course, the predictions are coming out to be fine, then you will go ahead and deploy your model. And if you just talk about the ML code, right? So about the entire ML system, the ML code is actually just not even like 5% of your entire technical depth that is there for your entire ML ecosystem. So whenever you're talking about any machine learning or ML ops system, we're talking about data collection, we're talking about the feature extraction, things related to the infrastructure, like to set up the infrastructure to actually host and run your machine learning models. Because typically your machine learning models require GPUs, and you might require multi-cluster GPUs to be able to run some of these machine learning models that are requiring a lot of compute. So the actual machine learning code, which is like writing your machine learning model, is very minuscule part of your entire machine learning systems. And this is where the power of DevOps style comes into picture, and that we'll actually see. So whether it's like monitoring your model once it has gone into production, or it's actually setting up the infrastructure for being able to actually run your machine learning inference. So what I try to say is that as development requires DevOps, similarly machine learning requires MLOps, right? And if you understand that what MLOps really is, MLOps is a set of tools and practices that apply the same principles of DevOps that is applied to Dev, but to machine learning. And machine learning itself, right, is very similar to your software development in terms of as we'll see that how, like, by taking some examples of CI/CD, you'll see that how replicable it is to be able to write those same set of scripts that you write for CI/CD for standard software, to be able to replicate them for being able to manage your machine learning models, so that it's like testing your models and then deploying your models, right? So that's what value I want to convey from this particular talk. Now, of course, that's just going to break down into the three major aspects of how CI/CD is primarily used in machine learning. So when it comes to your data, right? Because data is the king for machine learning. If you have the right set of data, then of course your models and the training that you do for your models will work pretty well. So whether it's like checking whether the data itself is accurate, doing data version control. So very similar to how you do you use Git to basically version control your entire code base. You can use machine learning data, like CI/CD data, for being able to ensure that whether the experiments that you're running, whether they are running on this correct set of data or not, right? Then when it comes to training, you'll be finding use of CI/CD within model training as well. So whether it's like choosing what type of algorithm to run, then selecting what kind of parameters should be required in order to optimize your machine learning model. And then when it comes to deployment, that's also a very important place where your CD principles will be used for model deployment as well. So whether it's like you have to deploy your model to production, or you want to make a canary release with the new set of model parameters that you just added. Because one of the typical use cases that you see is that, let's say, as a data scientist, you create a machine learning model, it goes into production. Now, one very important thing is that when you work with a model in production, the amount of data that you are adhering to, right, is you might have users from all over the world. There might be a lot of hidden edge cases where your model actually might start to fail. So what, as a data scientist, you will be required to do is you will be required to make incremental changes in your model as the model goes in production. And once you have made those changes, you have to also test the efficacy and the efficiency of the model after you have made those changes. And then you have to push it in production. Now, if you were not to use something like CI/CD, it would be a very tedious process because, of course, again, you're making these changes in your model, then you have to manually deploy them to production, test it in production, and this cycle for doing all of this in a non-automated way will require a lot of time and effort, and also money for your DevOps teams. So that's where you'll find a lot of use for CI/CD. And I just wanted to also cover this particular diagram. So this diagram is from Google Cloud, which kind of I hope it's visible to everyone. But in case it's not, I'll be sharing the slides at the end. But what you see over here is that first thing that we are doing is we are doing data analysis, where we are just ensuring that the data itself, whether it's good or not. Then we are doing the model training. Then we are pushing our model into production from the source repository, and we have our entire pipeline set up that allows us to automatically manage our data versioning and then pushing our model into production. And if we just kind of break down now the different steps, so of course the first thing that every data scientist starts off with is writing a Python notebook, right? As a machine learning engineer or as a data scientist, we are always writing these Python notebooks. Now, the Python notebooks are great for doing experimentation and running your inference, right? But there's no direct way of being able to directly just take your Python notebook and put it into production, right? So what you can do is there are a lot of different tools, and one of the ones that I personally work on is with the help of, for example, you could use Jenkins to break down your entire cells within your Python notebooks as separate Jenkins build tasks, and then automate that with the help of your Jenkins pipelines. Then when it comes to, let's say, your entire machine learning pipelines, there are tools like Kubeflow that allow you to automate that. Then, for example, if you want to integrate CI/CD unit tests or integration tests, we could use platforms like Jenkins or DBC, which is like an open source data version control system that I'll also be showing in a couple of demos. Then, for example, if you want to do the delivery, that's mean like whether you want to have a candidate release or you want to deploy your model in production in any of your clouds, then you can use tools like Spinnaker, which is an open source continuous delivery tool that allows you to actually do that. And this kind of showcases that, for example, you make certain changes in your configuration file and you can run some smoke tests. Or like, let's say if you want to go ahead and trigger, like you take new model changes, so your CD system can automatically determine what are the model changes that have taken place and directly go ahead and either create a canary release or directly push it into production into any system that might be used. And this kind of showcases the entire example that I kind of demonstrated with those examples. So what you see is that when you're making any code change in your machine learning system, Jenkins or DBC for that matter can detect those changes, push those into the continuous training cycle where you are basically doing your machine learning inference on the new set of data that you're training on. And once you have seen that, okay, whether the tests that you're running, whether those are good enough to be pushed into production, then you can use CD systems for doing your deployment. And of course, the use case that I mentioned, right? So this was the first use case that I personally got to work on. This is the Jenkins machine learning plugin. If you are interested, you can check it out. It's the link for so it is actually part of the Google Smart Code project in 2020, where you basically take your Python notebook, add a custom kernel to your Jenkins so that it can detect an IPython kernel for the Python notebook, and then take all of your different tasks, whether it's the feature extraction or model training or model evaluation, and have those as separate Jenkins build steps. And it can automatically generate reports and logging for you with the help of the entire Jenkins pipeline. And the other one that, of course, that I'll be demonstrating right now is that how you can very easily do things such as your model evaluation and training directly with the help of GitHub Actions. And that's what I'll be showing in my demonstration as well. And of course, the other one that I also mentioned earlier was related to DevOps, which is like similar to how we have Git for being able to manage your or version control your software, right? Similarly, it's very important to also version control your data as well. So the use case over here is that, for example, you write your first ever line of machine learning code and it works well. You push it into production and it works on a certain set of data, right? Now, of course, as your model kind of evaluate, your model kind of grows, there might be some changes that you might make in your input data set that was initially used, right? And you might have different versions of your data set. So it's also important to track that what type of model evaluation was done on what specific type of data, right? What type of input data? Because of course, data within any space of machine learning plays a very important role. So with the help of DBC, which is an open source data versioning tool, you can keep track of what particular type of input data was used and the corresponding evaluation that took place with that particular set of input data set that you have. So essentially, if you're running multiple experiments, you might have, like, let's say 3 or 4 different versions or iterations of your data set. You could very easily just maintain a log of those data sets and the corresponding model evaluation that had taken place with that particular data set. So that you can very easily manage that with the help of these. So coming on to the demo, right? I have prepared 2 separate demos. One is a very simple, straightforward demo that I'll run, and the other one is actually taking your data set, pushing it into an S3 bucket on AWS, and then running your inference from there. So before I move here, and this will be part of my second demo, but let me first go to my first demo. So I hope everyone is able to see the screen. Is it too small? Oh, okay. Perfect. I hope that now it's visible to everyone. Perfect. So over here it's a very simple example where I have this use sklearn and I'm using a random forest classifier to do my model metrics. And what I've done is over here, first let's go to the GitHub workflow because this is an example for a GitHub action, right? So if you want to work, if you have not worked with GitHub Actions is a set of CI/CD tools that are provided by GitHub. And in order to create a new GitHub workflow, you just have to create a you have to create a repository. Within your repository, you have to create a folder .github, and then within that you have to create workflows, and then you define your YAML file to be able to run that particular workflow. So in this case, if you see over here that I've created one workflow here for model training, and what it simply do is that it will go ahead and use the iterative setup CML. So CML is basically an open source tool for continuous machine learning, and this provides you very easy to use CI/CD pipelines for your machine learning projects directly in GitHub. And I'll be sharing a link for CML as well at the end of this talk. So over here, what you see over here is that we use the GitHub action for the setup CML, which is basically setting up our CI/CD pipeline for our GitHub action. And we'll simply just go ahead and we'll run our train.py, which is our Python package over here, our Python module. And we're simply just going ahead and running our machine learning model, generating the accuracy score and generating the confusion matrix. So for those who might not be aware what is the confusion matrix, it's basically a diagram that allows you to share like how many false positives or how many false negatives did you actually generate. So that's simply what I'll be doing over here. So as next steps, what I'll do is that if I go back to the CML, right? So what it's doing is that it's basically generating the logs and it's generating a plot which shows the confusion matrix, right? So what I'll do is I will go ahead and check out to a new branch, because what we'll do is that we'll see the confusion matrix getting generated on the generation of a pull request, right? So that's what we're going to do. So if you see over here, the action that I've done is that it will be an on push, and when I actually generate a pull request. So let me check out to a new branch, and I'll just call it test 3. And within this branch, what I'll do is that I will change the depth of my random forest classifier. So I'll change it to 7, let's say. And let me go ahead and push my changes now. And I'll go ahead and push my changes. Right, perfect. So let's go to my example over here and let's go to my pull request. Actually, go ahead and create a pull request. Now, as soon as I create this pull request, it will automatically start to trigger a new bit of action. So I probably set up a different one. Let me go ahead and leave. Set at the depth of 9. I will go ahead and just make these changes. what I want to do is actually run it on my own system. So let me probably change the repository, like the branch. Let me move back to main and first run this. Let's call it code and go ahead and run the same changes. Right. So once I've done that, I will go ahead and create a pull request. So let me go ahead and create a pull request, but for my own repository. Right. Right. So as soon as I create a pull request now, it will go ahead and start to trigger a new workflow. And this is basically the UI for the GitHub Actions. I'm not sure if everyone's able to see, but you can see that now the action has started to run. So right now what it's doing is it's running the iterative setup CML, which is basically setting up the GitHub action for doing the continuous machine learning. And it probably just take another like few seconds, and then we should be able to see the confusion matrix getting generated within our pull request. So the idea here is that as a data scientist, when you want to push your model to production, before doing that, you would want to test whether the performance of the model is good or not, right? And you might be doing this for multiple machine learning model changes that you're making. And what you can do is that you can set up your continuous integration for your model changes to ensure that yes, the changes that you're making actually make sense, and you can see that directly in your pull request. So if I go back to my pull request now, I should see a new confusion matrix getting generated, as you can see, and it also actually prints what's the accuracy of the model changes that you've made alongside the confusion matrix. Now, I think we are running slightly out of time, but the other demonstration that I wanted to showcase was it goes a bit deeper into being able to push your model changes into production, like into an S3 bucket, let's say. And the idea here is that let's say if you have a new model, you will upload that model to a remote storage, it could be an S3 bucket or any other cloud, and then you create a pull request, it automatically spins up a new bit of action, and if the changes that are there, if they are good enough, you can go ahead and merge those particular changes, right? So over here, what you'll see is that I have this run test, and what this does is that within this particular GitHub action, so this is a separate project, and I'll be happy to share the code with all of you to kind of follow along. So over here, what we're doing is that we are first creating a pull request, and on the creation of a pull request, you'll not be able to not just be able to actually test your model. So within these steps, you can see that it will install the dependencies, it will pull the data and the model, and over here it will pull that from the remote S3 bucket where you are storing your model, and then it will run the test with PyTest. So PyTest is a testing suite in Python to be able to run tests. And what you see over here is that we have written tests for testing the model as well to check whether the inference of the model is correct or not, whether there is any data drift or prediction drifts that has taken place. So as compared to your last time, what has been the total amount of change in the prediction result inside of your model, right? So these are your proper test cases that you might also write for your software as well, right? In a typical software sense. So you can run these tests directly and then also go ahead and evaluate your model as well, right? And it will finally then go ahead and create a report for you. So as an example of here, like this was one of the tests that I just ran, where so the model that I was running was basically a SVM, which is support vector machine learning model. And over here, I made some incremental changes to my model. And what you can see over here is that it automatically triggered that particular pipeline, and it generated again the accuracy of the model and then some other parameters like hyperparameters that you can see over here. And to kind of see like how that particular action looked like, so it is basically this one, which is the change SVM kernel. You can see over here that this is the entire workflow where it first goes ahead and installs the dependencies, runs all the different tests that we have written, right? So when it's like running the tests on your processing of your data or the actual model itself, right? And the evaluation of the model. And then it will go ahead and evaluate the model, and it will create those reports for you. So that's the use case that you see that, right? As with any DevOps project, if you're running it on a normal application, you'll have you'll write your code, you will build the code, you will run your tests on the code. If the test pass, only then you will go ahead and push your code into production with a CD system, right? And that's what we are seeing over here, that we can very easily replicate those same principles, but for a machine learning workflow. And again, whether it's version control or whether it's testing your code with machine learning, it's very relatable to your standard software, right? So as I go ahead and end this, right, I'll go ahead and run another code. So I request all of you to scan this particular code again. This is a separate code. And the question is that if you're not already convinced that CI/CD is for machine learning, I hope that you're convinced now. So if we can just simply answer this code, it would be really great. If we get one yes, I mean, I think like that would be great. But yeah, I mean, the main demonstration that I want to showcase is that it is as simple as like doing CI/CD or DevOps that you do with your standard software development processes to replicate that directly with ML, right? And the great thing about ML right now is that as these tools for MLOps they increase, right, they become better, because of course MLOps is still something that's new, and it has been there for the past like few years, and it's a growing thing, right? So the tools that are being used for MLOps are also growing at the same time. I was just having a discussion with other folks from the conference that OpenAI, like they are today being like how they're able to run is that they use Kubernetes and they have multiple 500,000 plus clusters. They're running GPUs and all the machine learning inference is taking place on those GPUs. So they are extensively using MLOps, and a lot of different teams that today are having AI-based products or they're using machine learning internally are utilizing the same set of DevOps tools or similar set of DevOps tools that you might use for your DevOps use case for a normal software as well, right? So I think like 88% is it's a pretty good number to kind of take a validation that yes, everyone does agree on that particular fact. And I'd like to conclude with some resources. So feel free to take a screenshot of these resources. So primarily, one of the ones that you see over here is by Saifal, who's like an MLCD, and the one that he covers is basically how you can set up CI/CD for your machine learning systems, but with GCP, which is like Google Cloud Platform, right? And going back over here, the other ones that I covered are CML, which is basically your continuous machine learning that provides you GitHub Actions to be able to automatically generate test cases for you and do the model evaluation with the help of your GitHub Actions. And the one that probably I'll recommend to everyone is this mlopsguide.github.io. This kind of walks through each and every step of how you can create your own GitHub project, set up your GitHub Actions, and of course, like you can replicate this for other CI systems as well. So whether you're using Circle CI or any other internal CI pipelines, those should work pretty well, similar to how we showcased the demonstration for GitHub Actions. And yeah, that's it. I'll be open to questions now. And if you want to connect with me, you can connect with me on my Twitter @redhotwella. And I'll be open to questions now. Thanks so much.
Does anyone have any questions? Oh yeah, sure.
So for this type of CI/CD pipelines, one thing that I've heard is strict people trying to have problems with the data movement of like models are not like 1 meg files that you move around, or these models are a large amount of data. So what are kind of like the latest tools or like modern tools to deal with, or maybe practices, but also costly?
I plus one that question. Last time I looked at this, this was a challenge.
Yeah, so as you might have seen that I covered the tool like DVC, right? So it's like data version control. So that actually does play an important role in being able to manage your data. So of course, like transaction of the data or moving the data around can be an expensive affair. So whether it's like being able to make incremental changes to your data or having different versions of your entire dataset, and those dataset could be in gigabytes of size or petabytes of size. So DVC as a tool can very easily do that data versioning management for you. So whether it's like you're hosting your data remotely on an S3 bucket or any other S3 compatible or S3 compatible data store, so you can very easily just manage looking at whatever latest changes have been made to your data, or very easily just refer to that particular data set with the help of DMC. So that's of course one tool, but that's one of the most popular open source tools that are there that can very easily handle that.
Thank you. So, maybe I missed something, but try to look at this situation from the different angle. So, in DevOps, we have a huge amount of data. We have the metrics from the deployment, from integration, monitoring. So, finally, it's a huge amount of data. Can we use machine learning to analyze this data and create predictions? So what the benefits we can use from this approach? So that's did you try to look at this idea on this?
Yeah, so I think that's the beauty of machine learning, right? That of course the use case that I kind of covered was that how DevOps is useful for machine learning project, right? So when it comes to deploying your machine learning model or making those incremental changes, and then of course I didn't really cover things such as Prometheus or Grafana or doing like observability on the machine learning model predictions as they are being run in production, right? So other one could be that a lot of DevOps teams use machine learning for anomaly detection, or of course, as you generate these logs, you could use specific machine learning models to see how how these logs are getting generated over time, and try to generate some insights from that, so that it can actually help you improve your DevOps process as well. So of course, like applications of machine learning can be applied to that entire DevOps pipeline that you're running for your model training and pushing into production, and those can be used to optimize your DevOps principles like that you're using.
All right, well, we're going to take a quick break now and come back at 10:40. Thank you. One more round of applause for Shiva. Amal? Yes, yeah. He literally flew all the way over here from India to do that talk. And I remember when we were doing speaker selection, like that really popped out because I think in the past few years, we've gotten a lot of feedback for like machine learning, data, bringing more of those topics into this conference. And I hope you see that we take that feedback seriously and we're trying to find good speakers to go into that topic. All right, let's get this rocking and rolling. Tim, are you almost ready? Putting the ocean space up. Okay. All right, can we get a big round of applause for Tim?
Hi, everybody. Hello. I am Tim Becker. I am the engineering lead for the software platform at Gecko Robotics. Over the past year and a half, my team and I have built out the DevOps at Gecko pretty much from scratch. Specifically, we built out the internal cloud development platform and platform engineering. I'm going to talk through my experience, what went well, what didn't go well, our approach, and some specific decisions we made. I was lucky enough to have fairly ideal circumstances for building out the platform, so I thought I'd share those experiences, the sort of case study or conversation starter. What we built is definitely not a paragon of internal development platforms, not yet, but it's real and it's working. So a bit of my history, I worked at a couple different kinds of DevOps teams. I learned a lot from each, and each had their share of successes and their share of anti-patterns. I kind of fell into DevOps, and the first team that I was on was more of an internal tooling team. We built our Jira instance and managed that, as well as our CI/CD pipeline source code repositories. And we had a lot of pointless gatekeeping there too, or I'd jump on a call and click a button on a CI/CD pipeline that I'd never seen before due to some out-of-date compliance regulations. So I learned a lot there of like what it could not look like, but I also learned a lot of things that I took on to my next roles. Then I transitioned within that company to more of a platform engineering team. And that's a lot, we didn't call it that at the time, we didn't know that term. But that's a lot of where I learned a lot of what I do today. Unfortunately, we didn't have good access to the users, so what we built was really great, but it was a little overcomplicated. It was hard to onboard people onto the platform, and yeah, it just wasn't what they needed. But it did, again, have a lot of shared successes, and I especially learned a lot at that position. Then I went to a new company. I transitioned back into software development for a little bit, still had my hands in cloud stuff, that's what I was actually good at. Then transitioned within that company back to DevOps into more of a, we're ops, but we do dev stuff kind of role. And again, share of successes, share of anti-patterns, good learning experience. Yeah. And then I started at Gecko. What does Gecko do? We build wall climbing robots that inspect infrastructure. We take that data, upload it to the cloud, process it, and present that data to our customers to drive decision making around the life cycle of that infrastructure that we inspected. We work with power companies, oil and gas, pulp and paper. We started working with U.S. military, inspecting ships and missile silos. So if you're interested, you can go to our website, geckrobotics.com. There's some fun little videos and stuff there. But I'm not trying to sell you anything unless you have an industrial-sized boiler in your basement. I'm telling you this just to contextualize where I'm at, which is right there in the cloud. That's most of what I've worked on so far at Gecko. So when I first joined, one thing that really surprised me was that DevOps culture was already pretty strong there. The teams built their stuff and owned it all the way from their IDE to production. We had strong documentation culture. There was lots of automation. People were interested in doing the right thing. So one thing I had to be careful about was to avoid the anti-pattern of when you have a DevOps resource, they become DevOps. And all of a sudden, people aren't owning their own solutions from all the way into production. If there's a cloud issue, you reach out to DevOps and ask if they can figure it out for you. So I had to be careful that I didn't ruin this, that with the culture that was already there. And part of this, trying to brand ourselves well, was a recent rebrand from the DevOps team to the software platform team. We couldn't be platform team because we also have a robotics platform. And this was really to be clear about what our purpose is and what we're working on, which is the platform. Even though there was really good DevOps engineering, DevOps culture there was a lot of things that were slowing down our software developers. And a lot of these had to do with because all of the engineers that were there so far were focused on their unique problems and what they were trying to do and didn't have this wider scope. So we were redoing a lot of work over and over again in each of our applications. And that's why, I mean, this was fine, it made sense. It was where a lot of startups are and a lot of companies are, where you throw stuff at a wall, see what sticks, and a lot of times you have a lot of crap left over that you gotta clean up later. And that's how you need to start. But eventually, as we tried to scale, that's why we needed a DevOps resource to help us scale and to have someone who cared about these little things that the other people don't have the time, bandwidth, goals to be able to focus on. And fortunately, like I said, there was a pretty ideal solution for building it out. It was small, so we were able to focus on a few things, keep it simple, and really do a few things well rather than trying to do everything at once and be everything, do everything for everyone. We also had an engaged team, people who we were able to work closely with and get good feedback on and get contributions from. A lot of the early platform and the platform today is directly from contributions from the teams and not our work directly. We were also greenfield with a clear-ish direction. We had a lot of existing things, but we decided that we would start to build from scratch and learn from the previous things that we had. And also, the work that we're doing was important. We just got our Series C. We're building a new business model with our software. So we had good runway, good support, and so we had the time to try to do things right instead of trying to rush solutions and fix gaps that we had in place. But even though, like I said, it was clear-ish direction, we pivoted a lot at first, which was actually pretty nice. We were able to get a lot of reps spinning up new applications, learning from our mistakes there, and not having those mistakes follow us for the rest of my time here at Gecko. We were able to shed a lot of that early tech debt and learn from our early wins and mistakes. So now, this is probably a little generous, but this is where we're at. We have a lot of standardization, automations, and we're really heading in a good direction. So how do we get there? First of all, I'd like to talk about platform engineering in general. So what is platform engineering? This comes from basically how do you do DevOps? Like I mentioned earlier, I think there's a lot of wrong ways to do DevOps. I think the first people who describe it best is team topologies. They have DevOps antitypes that are really good at describing ways that DevOps isn't as effective as what it is doing what it's set out to do. And DevOps teams can get in the way or create their own silos. They also have ways that DevOps teams are effective, and those have really good descriptions. But personally, I like to oversimplify it into just two categories: site reliability engineering and platform engineering. And there's a lot of crossover between the two, but it really comes down to what is your goal? What are the things that really drive what you're doing day to day? Where site reliability engineering is mostly focused on system reliability, platform engineering, the main focus of our team is to empower the engineers that are around us. So we don't have our hands in the code, in the running code in production as much. We try to make it so people can do it themselves. And you can look at this list and see that there is still a lot of crossover. We still are concerned about performance, and SREs will still want to optimize software delivery. So there's a lot of crossover. It's mostly semantics. And what's most important is that you understand your goal and your role within the organization, and that is well documented, well communicated with everyone else in the organization. So for me, that means I need to be clear about my responsibility and my team's responsibility. For instance, if it's in the cloud, it's not necessarily our responsibility. It should be, if you built it, you want to run it. But that can be really hard. This expects a lot from software engineers, the you build it, you run it mentality. They already have all of their own problems that they're trying to solve and all their own skills they're bringing to the table. And now all of a sudden they need to be cloud experts and be experts in everything that DevOps engineers are trying to do. So it's a lot to put on people. So platform engineering, the idea of what we're trying to do is make this easier on our teams. So they can actually succeed in the building and running it themselves. This is done through golden paths. We try to make it easy to do things right and hard to do things wrong. We have guardrails and we have things set up so that it's easy to get to where you want to go. Someone told me a long time ago, and it stuck with me, that it's really easy to do things in the cloud. It's also really easy to do things wrong in the cloud. You have these big, great cloud providers, AWS, GCP, Azure, that they have a lot of choices and they try to make it easy on you, but that's how we get a lot of these famous data breaches where if you don't know what you're doing, it's really easy to make things insecure and do things wrong or overcomplicated. So we try to opinionate this and make these golden paths. Another big concept in platform engineering and DevOps in general is cognitive load. And I'm sure, I know a lot of psychologists and other people on the internet can explain this better than me, so I'll just go through it pretty quick. But it's the idea that your working memory only has limited capacity. If you're trying to hold too many things in your head, then your ability to do anything suffers, and you have trouble focusing on and improving on the things that really matter, and the interesting problems that you're working on. There's three aspects of cognitive load. There's the intrinsic load. These are your skills, the inherent complexity of the task. This means that you can't pull someone off the street and they can develop a go backend for you. You have to have basic understandings of software engineering practices, languages, and yeah, these are the skills that you bring to the job. And this is something you can't make more simple. You can't reduce, but it's also not contributing to the actual problem that you're trying to solve, the interesting problems. Now, extraneous cognitive load, this is the irrelevant load. This is, where do I need to go to see my logs, to troubleshoot my applications, to debug? How do I deploy this again? Which Python framework is this particular one using, and how do I install something with that? This is having too many tools and frameworks and overcomplicating things. This is what, as a platform team, we're trying to reduce to make room for the remaining cognitive load. This is the relevant load, the interesting problems, the things, the differentiators that your company is solving for. And yeah, we need to make room for this by reducing extraneous cognitive load and not getting extraneous and intrinsic mixed up, where we think that this is just inherent complexity. You know, this is something that we can make simpler, so we have room to do the interesting things. How do we do this? Opinionate. One tool isn't necessarily better than another, but it's definitely worse to use a lot of tools to solve the same problem. And so we make a decision on how do we do compute, how do we, which tool are we using to install Python packages. And every time you run into a new use case that you might need another tool, you really need to be serious about a cost-benefit analysis of, is it worth adding the cognitive load to use this new tool for the new features that it's giving us? And sometimes the answer is yes, a lot of times the answer is yes, but you really need to be serious about taking cognitive load into that. Because if you do this well, you're able to automate everything a lot easier. If you only have a few set of services, your shared libraries and everything can only focus on a few, the few things that you have opinionated with. So that instead of having to target 5 different performance management systems, you can target just one. And that you don't have to keep everything up. You're able to do things better so that everything is interconnected automatically and everything just works together. So how do we do this at Gecko? It comes down to defining our purpose and keeping this in mind. And like I said earlier, really communicating this with everybody. So our core purpose is to